Clear? Hello?
Yes, sir.
Okay. Whenever the p-value is less than 5%, you reject the null hypothesis. Okay. Now
O-
this is the confidence interval. Okay, 95% confidence interval. That means for a 5% level of significance, what is the confidence interval? That is x bar plus or minus plus or minus plus or minus mu. Sorry, I'll copy this alone. Mu sigma. Mu sigma. What is the sigma? What is the sigma? Sigma is
Standard deviation.
standard deviation. Population or sample. Mu is population mean. X bar is sample mean. Sigma is population standard deviation or sample standard deviation. Population standard deviation. Okay, using the using the sample, using sample statistics, you estimate population parameters. Okay, using sample statistics, you estimate population parameters. What you estimate using samples are called statistics. Okay, based on the sample statistics, you are estimating population parameters. What are the parameters here? Mu and sigma. Okay, sample statistics, x bar and yes. Okay, this yes symbol. Okay, sample standard deviation. Okay. Okay, so we know that t test and z test are conducted when the and ANOVA are also conducted when the underlying population distribution is assumed to be normal. Okay, when the underlying population distribution is assumed to be normal, from that population only it is assumed that this sample has come. Okay, and when we conducted the analysis, we saw that we could reject the null hypothesis and we were accepting the alternate hypothesis. That is, there is significant difference. Okay, here you can put the wording like this. Okay, go to the word file. Okay, you can put the wording like this. The sample mean is not significantly equal to the hypothesized population mean. Why this significantly is because see, we are not having a exact distribution. Okay, we are not having an exact distribution, but we are having a population distribution. Sorry, stochastic distribution or probabilistic distribution. Okay, we are not having an exact distribution, or we are having a probabilistic or stochastic distribution. Right? Are you able to follow? Hello?
Yes, sir.
If we had an exact distribution, we would not include the word significantly. Okay, sample mean is not significantly equal to the population mean. Okay, because we are having a stochastic distribution. Okay, now we'll go to the R window. Okay, okay, so we'll now see how to so we have seen a test, right? Now we'll see how to install R in your system. Okay, so first go to the browser. Okay, Okay. Now I opened a new browser window. Okay, now go to Google, type download R. R. Okay. First you should download R. Then only you can go for R Studio. Okay. Download. So it comes right. Comprehensive R archive network. Okay. You can install from this. Okay. Download R 4.5.2 for Windows or for Mac OS. I have Windows, so I am going to show using Windows. Okay. Right click, open a new tab. Okay. You can see this here. Okay. Now download R 4.5.2 for Windows. Okay. Right click and download. Okay. So I already have an older version. Okay. For my suitable for my computer. So you should be careful about the versions. Okay. Slightly it can twist your activities. Okay, so just be a little careful, but R is more friendly actually. Okay, R is much more friendly, so you can download the R version for R 4.5.2 for Windows. Okay, just download and install. Do you want me to show the installation? Very simple, just few minutes it will install, not like other softwares. Okay, it will install very quickly. Okay, do you want me to show the installation? Hello.
No, sir.
Okay, not required, right?
Yes, sir.
No.
So one, yes, sir. So once you install R, you go for download R Studio. Okay. See, now itself you can try also. Somebody of you, one of you can try that. Okay, and you can see how quickly it will install. Very simple and straightforward. Okay, download R Studio for Windows. Okay, so R Studio desktop. Okay, right click, open. Okay. So one thing, only when you install R, you can install R Studio, I think. Okay, now latest version, I don't know. But before that, first you had to install R and you have to install corresponding R Studio version for the corresponding R version. Okay, so R Studio desktop. Windows 10 11, just right click and install. Very simple. Okay, very simple and straightforward. Okay, I hope you can do this. Okay, so I should I show the installation? Should I show you the installation?
Not required, sir.
Not required. Okay, thank you. Now I will go to the R window. Okay, and I will show you this this book we have written. Okay, myself and Sheikh Manzoor sir. Okay, we have written this book. Okay, a handbook of multivariate data analysis using R. Okay, so you can see this how R runs, how R is installed and how it is used to run. Okay, before that, you can once you install, you can go to the start button. Okay, it is not working because I have shared. It is heavy. Okay, I'll press this button. Still it is not opening. Okay, so I will minimize this. Let us check what can be done. Okay, I will minimize this. Okay, still it is not opening. Okay, okay, you can go to start and you can run R. Okay, very simple. Okay, now it has opened. Okay, now go to R. Okay, go to R and you can see R and R Studio here. Can you see this?
Yes, sir.
Just click on R Studio and you can click on this one. It will open R Studio here. Okay, like this it will open. Okay, sometimes your antivirus network may not allow. Okay, you can just bypass this, but it will open anyway. Okay, once you do this, it will open. Okay, start minimizing. Okay, gone. Okay, now see, I'll show you the book. Okay, you can see this here. Okay, we have done a normality test here. Okay, see, this is the normal curve, and this is the problem statement. Check the normality of the data presented here. The data contains a variable gold, which represents the price of 1 gram of gold over a period of time. It contains 203 observations in total. Okay, so you can see the data here, 203 observations. Okay, and very old data. Now gold is much costlier. Okay, so you can select the data here. See, I have opened a new script. Okay, it is also new script button. Okay, and commands are entered here. Okay, in the command prompt. Can you see this? Hello.
Yes, sir.
Okay, now new script is opened. It is like this. R script is entered here. Okay, and this is the problem. That is R script for the problem. Okay, my data, reading data from Excel. Okay, first line, then Shapiro.test of my data $gold. Okay, so you can see if your file contained, you can see this Excel file here. Again, see, if suppose I enter another column here, width. Okay, width. Okay, so 6 5 4 7 6 7 9 6 4 7. Okay, now suppose I go to my R window and I type dollar width here. Okay, everything is same. Okay, I have typed dollar width alone. Okay, or I will say one more thing. This is result 2. Okay, I will also have result 1. So you can see how I'm playing with the code. Okay, simply reducing the requirements for typing. Okay, I will say length. Okay, I will so I will run this alone. Okay, I'm not going to perform a t-test with this. Okay, I will read this alone. Okay, I will read this alone. Okay, and I will show you. Okay, so I will run this now. Okay, before that you need to run this one. Okay, I will go to the Excel file. I will copy the entire data. Okay, you can see here. Can you see this here? Hello?
Yes, sir.
I've copied the entire data. Right click, copy, go to R file, and I'm executing this first line again. Okay, I'm executing this first line again. Okay, and I'm directly coming here. I will do one more thing. I will type my data. Okay, this also I will display. Okay, now I will run this one. Okay, t-test is not required. T-test is not required. Okay, I'm not doing this. Okay, again I'm not doing this again. I'm just going to do my dollar my data $width. Okay, so I will run this. Okay, so you can see this here, my data $width. So this alone is displayed 6547 679 647. Okay, this alone is displayed. Now I run this my data line. Okay, you can see this, the entire data is displayed. Okay, you can see that the entire data is displayed here. Okay, entire data is displayed here. Okay, entire data is displayed. If I give my data, okay, see, my data is the entire data. Okay, that is what I have read here. And my data dollar width, my data dollar width is this alone. Okay, this data alone is displayed. Are you able to follow what I am explaining?
Yes, sir.
Yes, sir.
Okay, so okay, so this was about a very simple example. Okay, so look at this here. Script is entered here. Okay, that is what is indicated. Okay, and then you have to run this. Okay, how to run this? See, run button shown below in the boxes in screenshot is used to run the script one line at a time by placing the cursor on the line to be executed. Okay, place the cursor on the line to be executed. For example, I want to run this line alone. Place the cursor here, click the run button. Okay, click the run button. Okay, this line alone is run. Okay, now cursor automatically comes to this one. If I click run, this alone will run. Okay, this line alone will run. Okay, now suppose I want to run two lines at the same time. Select the two lines, click the run button. Okay, so this line has also been run once and this line is also run once. Okay, are you able to follow? Simple, right?
Yes, sir.
Okay, I think this is about it. Okay, for basics. Okay, now we'll go to two sample t-test. Okay, we'll go to two samples t-test. So you saw this here, right? You saw this here. There was one sample and there was a hypothesized population mean. Okay, is it visible or should I enlarge? Hello?
Visible.
Visible. Okay. uh okay, so now I will go for two samples t-test. Now let us assume we have two samples. Okay, let us assume we have two samples. Now let us assume there are two samples here. This is the first sample and this is the second sample. Can you see this here?
Yes, sir.
Okay, for simplicity, I will copy them to an Excel sheet. Okay, so that we can manipulate them easily. Okay, I'll paste them here. Okay, now okay, now this is length 1, this is length 2. Okay, this is length 1 and length 2. Okay. Now, see, very simple. Okay. What is the null hypothesis? What is the null hypothesis? There are two populations, right? There are two populations. What is the null hypothesis? There is no significant difference between the population means. Okay, there is no significant difference between the population means, or in other words, we can also put it as the difference between the two population means is 0. Okay, are you able to follow? Hello? Yes?
Yes, sir.
Yes, sir.
Or another way of expressing it, the two samples come from the same population. Okay, all of them are different means to express the null hypothesis. Okay, what is the alternate hypothesis? The two sample means are significantly different. Okay, are you able to follow this? Okay, before that, let me explain to you one tail test. Okay, we have seen two tail test, right? We have seen two tail test for this inequality symbol, right? One tail, for one tail test, left tail test, for left tail test, H naught is X bar is less than mu H naught. This is the left tail test. Okay, left tail test means X bar is less than mu H naught. Okay, what will be the left tail test? Are you able to understand? Are you able to understand what I'm doing? Hello?
Yes, sir. Yes.
Okay. Okay, so this is a left tail test. Okay, here it will be 5%, or that is equal to 0.05. This is the left tail test. Okay, right tail test will be right tail test will be this. Okay. Okay. This will be the right tail test. Okay. Are you able to follow? Are you able to follow what I've shown here?
Yes, sir.
This will be 5%. 0.05. 1 second, students. One second. 1 second. One second. Okay, let's continue. 1 second. Okay, so yes. So can you see this? Are you able to understand this? This is left tail test. Okay, this is left tail. One tail test, left tail test. This is right tail test. Okay, are you able to follow? Yes. Hello.
Yes, sir.
Okay, this is two tail test. This one is two tail test. Okay. Okay, now we will go back to this. Okay, now see, this is for left tail test. For right tail test, it will be x bar is greater than mu h naught. Okay, for right tail test it will be x bar is greater than mu h naught. Okay, this is the right tail test. Alternate hypothesis will be x bar is greater than mu h naught. Okay, now yes, so we have seen this. Now we will come back to two samples t test. Okay, so here h naught is h naught is mu1 is equal to mu2. There is no difference between the two population means, or there's no significant difference between the two population means. The difference between the two population means is 0. Okay, significantly equal to 0, and this one is okay. Okay, now this will be an inequality sign. Okay, inequality sign. Insert symbol inequality. Okay, so this is the two tail test. Okay, the two population means are equal is the null hypothesis, and alternate hypothesis the two population means are significantly different. Okay, that is the alternate hypothesis. Okay, are you able to follow? This is a two tail test. two samples test, two tail test. Why is it is a two samples test? Because simply because we have two samples, right? We are comparing the population means of these two samples. We are comparing the population means of these two samples. There is no significant difference between the two population means. The difference between the two population means is 0. The two samples come from the same population. This is different ways of expressing null hypothesis. Alternate hypothesis, the two sample means are significantly different. Okay, so that is how we have represented here. Okay, are you able to follow? Is it clear so far?
Yes, sir.
Okay, now we'll go to the R program. Okay, how to write the R code for this. Okay, we'll save this one. Okay, we will save this one as one sample t dot r. Okay, now we'll open another script. Okay, okay, new script is opened here. Okay, so we will copy this first statement here. Okay, reading the data is always going to be the same statement. Okay, we'll copy this first statement and paste it here. Okay, press enter. It comes to the next line. Now just go to the internet. It will not open. Okay, now instead of one sample test, go to Google. Okay, search R code for two samples t test. Okay, R code for two samples t test. Press enter. Okay, now you can go to this one, two sample t test in R. Okay, now come to this line here, just copy this. Okay, this is not required because we have already have the data. Copy this one. Okay, and paste it here. Okay, t test result, t dot test. Okay, t dot test. 1 second, students. Yes, so can you, yes, I hope it is visible. Okay, now yes, so t dot test, instead of heights underscore mail, what you will put is my data dollar length 1. Okay, then my data dollar length 2. Are you able to follow this? See, look at the data here. Is it visible? Hello? Hello?
Yes, sir.
Okay, you can see the samples here. This is the first sample, length 1. This is the second sample, length 2. Go to the R window. We need to compare these two samples. My data is the name of the data frame. Okay, this is where you have stored your data in Excel file. Okay, the data in Excel file goes to my data here. Okay, in that data, dollar length one. Okay, this one. Okay, this is the first sample. Then my data dollar length 2. Okay, this is the second sample. Okay, so you can run this test here. Okay, and the result will be stored in t-test result, and that can be displayed. Okay, that can be displayed. So we'll run this data. Okay, so how to copy the data? Go to this. Okay, select this, right click, copy. Okay, so now this moves to clipboard. You all know what is meant by clipboard, right? You all know what is meant by clipboard?
Yes, sir.
Clipboard. Just observe what I'm typing. Clipboard. Okay, this is nothing but it is a file where you're when you copy some data or cut some data, it moves to the clipboard. When you paste the data, the contents of the clipboard are pasted into your files. Okay, so what you're doing is you are copying this data to clipboard. Now in the R file, when I execute this line, when I execute this first line, the contents of the clipboard are sent to this my data frame. Okay, my data frame. Okay, so I will run this line here. I hope this is clear. Yes, what I explained now is clear.
Yes, sir.
Okay, I will run this first line now because I have already copied this content to clipboard. Okay, I will now run this first line. I have placed the cursor here. I will click on run. Okay, so now it is successfully read. So that is why this command prompt comes again. If you want, we can verify. Type my data. Okay, I have typed there. Click here. Okay, in the command prompt, type my data. Press enter. Okay, so you can see the data here. You can see the data here. Whatever we want is here. Okay, now place the cursor here in the script and run the second line. Okay, run the second line. Yes, so it is successful. That is why the command prompt has come again without any error message. So that means it is successfully executed. Now run the third line. Print the contents. Okay, print the contents of this data frame or variable. Okay, the cursor is in the third line. This is the cursor. It is in the third line. Now I'm going to click on run button. Okay, yes, so these are the results of the test. Okay, you can see here t value is minus 0.091928. Degrees of freedom is 17.428. P value is 0.9278. Okay, 0.9278. So see here, alternative hypothesis is given for our reference. Okay, we don't want to see this. Now what is the result? Can anybody tell me? What is the result by looking at the p value? Can anybody tell me?
H0 is rejected.
H0 is rejected. Why?
P value is lesser than the table value.
What is the table value?
2.19.
No, that is not table value. It is confidence interval.
Sorry,
No, your estimate lies between these two values. Okay, this is confidence interval. These are the confidence intervals. Okay, don't
Okay.
confuse confidence intervals. Your you can also look at this one and tell, but it is a different technique. See, your estimate lies between these two values. Now 0 crosses between these two values, right? Minus 2 plus, right? So that means your null hypothesis is accepted. We failed to reject the null hypothesis. Okay, now look at this p value and tell me. Don't go for that confidence interval. Look at this p value and tell me. Both are techniques which can be used, but look at the p-value and tell me what is the p-value.
0.9278.
0.9278. Is it greater than 5%? 0.05.
Yes, sir.
So if it is greater, what happens? So if it is greater, we accept H naught. Okay. If it is greater than 0.05, we accept H naught. Okay. There is another, see what you are talking about is T calculated is greater than or T tabulated. Okay. This is what you are talking about. Yes. This
Yes,
is
sir.
how you calculate, right?
Yes.
So going by your method, what is the T tabulated for 5% level of significance? Look at the T table. I will show you. Wait. Oh, this Internet Explorer will not open. Wait. Okay. Now I will type T tabulated or T critical. T tabulated for 5% level of significance. What is the T value? 2 to 2.2 or 1.96. So you have seen this. No. As degrees of freedom approaches infinity. No. See what is the degrees of freedom here? That also we will mention. Look at this here. What is the degrees of freedom? 17.428. Okay, 17.428. That also we will mention. What is the T tabulated value? 2.106. Okay, for two-tail test. Okay, so 2.106, right?
Yes, sir.
What is okay? What is the T calculated here? What is the T calculated? Minus 0.091928. Okay. What is the T calculated? Minus 0.091928, right? Minus 0.091928. Okay. What was the T tabulated? What was the T tabulated? Ayyo, it will not open. One second, students. Yes. So you can see this here, 2.106. Okay, 2.106. So I'll go to this 2.106. So you can see this here, T calculated is less than T tabulated, right? That means accept H naught, right? Right? Are you able to follow?
Yes, sir.
This is one way what you have studied. Okay, you don't need to calculate all this. Okay, if you are using a computer, it is very simple. Okay, just look at the p value here. Okay, if this p value is, if P value is less than 0.05 or level of significance. If P value is less than 0.05. Sometimes you will have level of significance as 1% or 10%. In that case, you have to use 0.01 or 0.1. So generally, in many problems, we have a level of significance as 5%. So if P value is less than 0.05, reject H naught. So in this one, you have to take absolute value. Okay, so you ignore the signs here. Okay, you look at only the magnitude. Okay, so I will remove the minus here. Okay, still it is less than 2.106. Okay, so now come back to here. If P value is less than 0.05, okay, P value is less than 0.05, reject H naught. If P value is greater than 0.05, accept H naught. If you're using computers, this is all you have to look at, P value. Okay, if you're using computers, this is all you have to look at, P value. Okay, you can look at confidence interval. Okay, you can calculate the T tabulated, T critical manually. Okay, by the way, T tabulated and T critical are the same. Okay, T tabulated and T critical are the same. Okay, is clear? Any doubts? Clear? Okay, now we have seen this, right? We have seen 2 sample T test, right? Clear? Any doubts?
No, sir.
Yes, so we need to look out only at the P value. Now you can see here P value is greater than 5%, 0.05. Okay, P value is greater than 0.05, so accept H naught. Okay, this is the same result we got here, right? Are you able to follow?
Yes, sir.
Okay, if you are using computers, all you have to look at is P value. Okay, so see, we have just 10 minutes now. So do you want me to go for one more test? Can we go for one more test very quickly into ANOVA? Hello? Can we go very quickly into ANOVA? Any response? Hello? Hello? Can we go quickly into ANOVA? We'll finish in short time, so that in the next few days we can go into multivariate data analysis. Okay, tomorrow we will see some more tests in univariate and bivariate. Okay, after that we will go to multivariate data analysis. Okay, so you don't have to worry about them. Okay, just listen for some time. It will be some introduction. Okay, if you are not able to at least understand completely, you will understand something. Okay, it will be useful for your careers. Okay, it is the basis for data analytics. Okay, yes. What do you want to do? Can we go quickly into ANOVA? Hello, can we go quickly into ANOVA? Yes, somebody. Yes. Hello. Yes, I will proceed now, so that we can go for other tests also. Okay, so what is ANOVA? See, it is very simple. ANOVA is again used for comparing means. Okay, we had 2 samples here. If more than 2 samples are there, we use ANOVA. Okay. But there is a slight difference. At least one of the means is different. Okay, is significantly different. Okay, it is not mu1 not equal to mu2 not equal to mu3. It is at least one of the means is significantly different. That is the alternate hypothesis. Okay, are you able to follow? Yes. So we'll quickly go to length 3 here. Okay. Yes. Are you able to follow? Hello? 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 No response? Are you following? Hello? Hello? Somebody please respond. Are you following?
Yes, sir.
Okay. I hope you are following. Okay. Please listen. It will be useful for your careers. Okay. So I will again do the same thing. Okay. I will before that let me open another script. Okay. I will save this.
Ganesh,
Yes, sir.
I hope we can continue multivariate analysis tomorrow.
Oh, sir. We have a Z test also, sir. Okay.
No, almost time up actually. Let them
Time up.
learn
Okay.
slowly. Yeah.
Okay. Okay. We will go for multivariate tomorrow, sir.
Tomorrow, is it also we can do it tomorrow. Yeah,
Okay. Okay. Okay, sir.
Wind
Okay.
up now. Not
Okay.
tomorrow. I'll tell you when. I'll check with the students. Availability. We'll
Okay.
do it.
Okay. Okay. Okay, sir.
Okay. Okay. Thank you, Ganesh. We'll
Okay.
meet again.
Okay, sir. Okay.
Deepika, we will meet again. Take attendance. We'll see.
Yes, sir. I've taken the attendance, sir. I've shared the absentees with you.
Okay. Then every one of you kindly do download the R programming and work 2 tests. Today we have seen, right? One is T test as well as
Two samples. Two
2
samples.
sample T test, student T test as well as 2 sample T test. We'll see you next class. Thank you. Good night. Thank you, Ganesh, for
Okay,
sparing your
sir.
time.
Yes,
Thank you,
sir.
sir.
Thanks.
Okay, bye.
Thank you, sir.
Okay.
Thank you.
Okay.
Thank you, sir.
Okay.
Thank you, sir.
Okay.
Thank you.
I hope the class was useful.
Yes,
Yes, sir.